All right, the purpose of this video is to talk about unit conversions. And in the modern era, normally people just Google everything, but I'm going to say a few things about this. Hold on. Why you might want to care about this. Sometimes you have a bunch of different numbers from searching the web or doing measurements in different types. Sometimes you might have inches and meters and all mixed together. So we really need to do these conversions for our answers to make sense. Most, but not all conversions are on Google. So on rare occasions, you may actually need to know this process, believe it or not. Most of the time, no. Most of the time, you're just going to plug things into Google in the lab and get it done. But whatever. And sometimes, if you kind of learn this process, sometimes you can actually make your own conversion factors that incorporate a number of different measurements. And so you just have to type in one number and convert it to the thing you care about, like dollars you need to spend or inches of rope you need, etc. So every once in a while it comes in handy. I think that's enough said on that. So what do I mean by this? Let's start with a simple one. I know that 2.54 centimeters is 1 inch. Immediately something might come to your mind, sig figs. Unless otherwise specified, assume conversion factors have infinite sig figs. So we're going to assume that this is actually 1.0000000, and this is 2.540000 out to infinity. So we're assuming this is exact. In rare cases, if it's actually specified, like 1609 meters is 1 mile. If I'm not mistaken, I want to make sure I get this right. Yeah. So sometimes I will give a conversion factor like this one, where I will underline it. And then in this case, this has 4 sig figs, and this has infinite sig figs. So on rare occasions, it is possible for a conversion factor to change your sig figs, because it could be the limiting number of sig figs if all of your measurements have 5 or 6. But generally speaking, converting units should not change the number of sig figs. And that is something that I will not try to trick you on test day. So generally speaking, when we're doing unit conversions, the sig figs of the number you convert should equal the sig figs in the number of sig figs in your original number should equal the number of sig figs in your converted number. Let's do a quick example. Let's say I have 6.0 inches and I want to convert that to centimeters. What do? Classic thing is to take this conversion factor and make a fraction out of it, right? So I'm going to put the 1 inch on the bottom and the 2.54 centimeters on top. I see that the inches would cancel and I would be left with centimeters. I punch it into my calculator. I get 15.24 centimeters. A quick comment. How many sig figs should this answer have? Depends on who your teacher is and what the subject is. This has 2 sig figs. This has infinite. This has infinite. We'd expect 2 sig figs. However, in a lot of engineering courses, your instructor might ask you to include an extra digit if the first digit is a 1. So for me, you can call this 15 centimeters. Somebody else might call it 15.2 centimeters. And this comes from the error associated with this. If I look at this right here, if I take 1 and divide it by, 0.1, the 1 in the rightmost column, divide that by 6.0, I get about 1.6%. Let's say 1.7%. So assuming I'm off by 1 in this digit, I get a 1.7% error. What happens if I put a 1 in this digit? 1 divided by 15, that's closer to, so a 1 in this column is actually a 7% error versus a 1 in this column, 0.1 divided by 15.2 is about 0.7%. And so you could ask yourself, which of these 2% errors is actually closer to the original number? So when we have the first digit being a 1 and we include an extra digit, usually the percent error more closely reflects the original number. So I would say 0.7% is probably more like 1.7% than is 7. If you're wondering why we do this crap with the first digit being a 1, keep an extra, that's why. That said, on my test, I'd take either one of these two and I'd be fine with that. That said, strictly speaking, why not just write it like this so it's very clear? You can write it as 15.24, or whoops, 15.2, underline that digit. This is probably the best way to write it on my test. You better talk to your engineering instructors and see what they want if you have somebody other than me. Everybody's different, whatever. All right, that's one conversion, but that's so far not too bad. Again, you take the number, you plug in the conversion factor, and you crank it out. Make sure you put the right numbers in the right place so that the units cancel out and you get the units you want to convert to. Let's do one where there's a square or something like that. Whoops, come on. Come on, there we go. Let's say we have G is a number. Let's say it happens to be 9.8 meters per second squared. And I want to convert this to feet per hour squared. All right. Well, I know that there's 1609 meters is 1 mile. I also know that there's 5,280 feet in 1 mile. So those just have to be numbers I recommend. You could also look on the back of your textbook and see if it's got anything there. You could use inches, I guess, right? So I guess another thing you could do, you could use, there's 12 inches in a foot. Whoops. And then you could use, there's 2.54 centimeters in 1 inch. And there's 100 centimeters in a meter. So you could use a meter and go to centimeters and go to inches and go to feet, right? Or you could use meters and miles and feet, either way, something like that. And then maybe I'll bring this up. You probably know that 60 seconds equals 1 minute. And 60 minutes equals 1 hour. You do 60 times 60, a lot of times we'll write this as just 3,600. So that's a common way to write it. Just use this one, and I think this one I gave to you on your test. Yep, I think I gave you all these. So if you look at your equation sheet, if you're worried, do I need to memorize this? Look at your equation sheet on your test and see. And again, get the workbook, look on the back, see where it is, okay? All right, and for now, let's just assume these all, and I want to check this 5280. I'm going to assume this one, all of these have 4 sig figs. Everything else that doesn't have an underline, we assume has infinite sig figs. Infinite, 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 infinite. All right, so let's go to this. I know I need to get rid of the meters, so I know that if I compare these two, I can actually make my own conversion factor. I know that 1609 meters corresponds to 5,280 feet. I'm not changing the number here because this is 1 mile under 1 mile. So 1 mile over 1 mile, that's 1. It's a very weird looking 1, but this is the number 1. Those each have 4 sig figs. This has 2. Don't have to worry about sig figs. Now, when I look at this, that's going to take care of the meters. How do I take care of the seconds? Well, I know that there's 3,600 seconds in 1 hour. Now, this is not going to get the job done yet. Take a look. Look carefully. The seconds are on the bottom, so the number associated with the seconds goes to the top. The hours go to the bottom, but this is seconds squared. Here's the big thing. Pay attention. If you want to square the unit, you have to square everything, the numbers and the units. If you remember to do that, you should be fine. I'm gonna go to my calculator. You can punch it in however you want. 9.8 times 5280. I like to go all the way across the top. Times 3600 squared. Then I'm gonna go back and divide by anything on the basement. Divide by 1609, divide by 1, done. So I got a really big number. This is kind of annoying. So I'm gonna change the notation just to make it easier to read. I'm gonna go scientific. So I'm gonna go to scientific mode. And I get 4.168 times 10 to the 8. Let me make sure I get the right units. Second squared, meter, okay. So now in this case, let's check the sig figs. 2 sig figs, 4, infinite, I only need 2 sig figs. So I should probably write this as, oh, whoops, I forgot the number there. 10 to the 8th. Sorry about that. Now, here's where we might want to do a reality check. I know this seems a little bit crazy, but this number here is about 3, right? Think about it. There's about 3 feet in a meter. Okay, 3.8 or something, I don't know. So in this case, we're talking about 30 feet, approximately 30 feet per second squared. So this is about 30 feet per second squared. And now what we're doing is we're converting the denominator to hours. We should cover a lot more feet in hours squared than we did in seconds squared. So it makes sense that the exponent is big and positive. So that seems about reasonable. All right. So moral of the story, when you're doing your conversions, usually we ignore sig figs, assume everything's infinite unless you see one of these underlines. Usually your answer should have the same sig figs as the input. And finally, if you have some unit squared, don't forget, you not only square the unit, but also the numbers, and you have to square everything in the numerator and denominator when you're doing that conversion. That's unit conversions. We use them all the time. Get good.